well said that it's not about a grand innovation. It's about a lot of little innovations every day, every week, every month, making something a little better. Inspired by these words, we have taken a small step towards innovating things. A very warm and heartily welcome to all the viewers. Myself, Ishita Verma. I am pursuing BTech from Sri Vaishnav Vidyapeeth Vishwavidyalaya and my branch is Electronics and Communication.
Myself, Amar Singh Thakur. I am pursuing BTech from Sri Vaishnav Vidyapeeth Vishwavidyalaya and my branch is Electronics and Communication. My contribution towards the project is embedded system and machine learning.
My name is Nikhil Trivedi and I am pursuing my BTech degree from Sri Vaishnav Vidyapeeth Vishwavidyalaya. I come from Computer and Communication Engineering branch and my contribution towards this project is cloud and simulation.
Myself Shreya Kanoje and I am pursuing my BTech from Sri Vaishnav Vidyapeeth Vishwavidyalaya, Indore, Madhya Pradesh. I belong from Computer Communication branch and my contribution to my project was an application development and user interface.
Me and my fellow team members are going to present the objective of our project, that is deployment of an artificial plant called as Bonsai, the smart plant.
There was once a courageous man, persistent to make world spick and span, went ahead to clean every corner and edge, to clean is to change world as he pledged. He was astonished to find pollution being culminated, albeit more petrified as his own house was highly contaminated. Sooner he realized far-reaching implications that home pollution is also very hazardous to our nation. We spend 90% of our lives indoor. According to Environmental Protection Agency, our indoor contains nation's worst pollution. Allergens which cannot be seen but are becoming the reason for nearly 5 million deaths every year in India. According to a study in California, failing to meet clean air standards cost healthcare payers $193,100,184 for hospital care alone. In other words, improved air quality would have reduced total spending on healthcare by $193,100,184 in total. Therefore, we spend most on the pollution and allergen related healthcare than on any other necessities that we have.
Indoor air pollution accounts for 4.3 million deaths annually. Of this 4.3 million deaths, 34% deaths are from stroke, 26% deaths from heart disease. Pneumonia and lung cancer account for 12% and 6% of deaths respectively. Women and young children are particularly vulnerable. More than 50% of pneumonia deaths among children under 5 are linked to indoor air.
Coming to the problem statement, we have some basic questions to ask. Do you ever find it difficult to maintain a healthy indoor due to your busy schedule? Is it difficult to detect gas leakages in your home? Is it difficult to keep your surroundings pollution free? The answer to any of the above questions is yes, then IoT-based smart plant, that is Bonsai, is the solution to the problem you have been looking for.
Following will be the major problems. The first one, air pollution has become one of the major concerns in almost every part of the world. We need fresh air to live a healthy and full life. But residents of many major cities around the world are plagued with smog and poisonous gases from motor vehicles, power plants, and factories. Locating a purifier is again an issue. Which purifier is to be located in the complete pool of purifiers in the campus or the institutions. Also, these purification devices are costly and require high maintenance and labor costs. Thirdly, we can say that the real-time status of purifiers is not known. There is insufficient time to schedule repairs and so reactive maintenance costs are high. The fourth major issue is of gas leakage, which is necessary to detect and to avoid any accidents. Exposure to odors could result in health effects ranging from none to mild discomfort to more serious symptoms. Some of the additional problems are, while air filtration technology based building ventilation can remove air pollutants and increase indoor air quality, filters increase the system's energy consumption and operating cost. The energy consumption is related to filters resistant to air passing through it. The resistance increases when the filter is fouled and causes higher energy consumption. Again, a problem is acoustic impact and non-uniform thermal environment that would occur by air filters. In order to achieve sustainable indoor environments, these problems need to be addressed. Also, there is no inclination towards the data availability to the users, and so there is no though on the maintenance procedures. Our use case proposes the basic idea of creating a fresh and lively atmosphere in your central. Sterile surroundings make us happier, more predictive, and adaptive. It said prevention is better than cure, so I guess all should take the preventive measures as per our surroundings. It said that if you breathe cleaner air with the help of air purifier for even 12 hours, your exposure to toxic gas is cut by 50%. In other words, you reduce your risk of diseases by 50%. Coming to the stakeholders which we can have in our designed smart ambience. The first one is the dealers and suppliers. Then comes the technicians, consumers, tier 1 suppliers, sales management or the manufacturers, then the maintenance and the management, etc. Now I am gonna address the issues to the main 3 stakeholders, that is to the customers, technicians and the service providers one by one. The first is the issue caused to the customers. Customers basically have to deal with 3 issues. First one is not having real-time information of the quality of the air in the purifier plant. Customers inhale the air without having or knowing about the quality of the air. Second is the trouble connecting to support personnel on the go. Third comes the domestic users are not aware if the scheduled changes of filters, they need regular notifications. Coming to the issues to the technician. Issues with technical competence. Technicians keep changing and not everyone is equally trained for fixing all issues. Some are entry-level technicians who need step-by-step guidance. Second is the real-time status of purifiers are not known. One technician may be tagged to oversee a certain number of purifiers which he checks once in a while. In the interval between issues could have crept in, not able to predict parts or tools required for repair. The third is when a purifier plant is known to be faulty, there is no information on what could be the cause of the problem. Sometimes things go out of stock. Locating a purifier, we just know that there is an issue. Which purifier is to be located in the complete pool of purifiers in the campus or the institution. Issues to the service provider. The service provider doesn't have a real-time view of the purifiers across locations. What's the health of the purifiers across the location could not be monitored from a single place. Not able to stock parts as requirements are very random, this often leads to stock unavailability of parts. Scheduling technicians according to the expertise required in the real time. Issues common among these stakeholders are reactive response to problems and only when users report them. Too much time, simply validating user complaints of problems. Finger pointing between teams produce delays in problem resolution. Challenges in actually solving the problem. Poor reception of service by internal and external customers. Limited ability to establish SLAs that are meaningful to businesses. Guesswork on the need for change and its effect on the business. Poor insight to IT's impact on customer service and workforce.
The objective of the proposed solution is to provide an ambient and smart environment to indoors, to consistently aware an individual of the quality of air she is breathing, to ensure home safety from any gas leakage and fire accident when user is away from home by sending SOS message, to provide a cost-effective option to a consumer for purifying his home environment, to improve the service quality provided to a consumer.
So here we present to you Bonsai, an artificial plant which brings you closer to nature. So Bonsai, it keeps a track of the indoor air quality and it notifies about the odor and allergens present in air by turning its color to red. And just like our natural plants, Bonsai also purifies the air. It detects leakage in your LPG cylinder and alarms you over your smartphone, giving you the required information related to it. And not only that, Bonsai also detects any fire accidents and alarms you over the application when you are not at your home or you are far away from your home.
Here is the computer-aided design of the proposed system. The system is proposed to be an artificial plant. The blower and the HEPA filter for air purification will be at the bottom part of the plant, which is the pot. The air will be entering through the filter and the purified air will be emanated through the pores of stem and leaves. This will be a challenging implication. The sensor placement is an important step for accurate delivery of the service. Therefore, we will be employing the necessary sensors for air quality index updates at the upper half of the plant, except for some sensors which will be embedded with the motor for condition monitoring and predictive maintenance.
Now coming to the description of the proposed solution. Now the proposed title is termed as Bonsai. Objective of this project is deployment of an artificial plant which can reside in any place of your home and it will help in maintaining a healthy indoor. Now after analyzing various surrounding detection systems, we pinpointed that there is a strong demand for a smart system just like the smart plant. Now which predicts and it helps in providing factual ways of correcting the machine failures. Now the system will purify the surrounding ambience. Now the system will consist of the following functionalities. First, there is an inbuilt air cleaning power which not only removes the nasty stuffs but also various dust and allergens. Secondly, it detects the bacteria, germs and viruses and other allergens and makes your air allergen free. Fourth point, it detects the odor and in case of the foul odor, it not only removes it but it also provides with a delightful fragrance.
So, the proposed solution for our stakeholders is as follows. Now, firstly talking about the customers. Now, it is very user friendly as it provides us with a touch screen. It will have all the vital parameters sensed from the output air of the purifier smart plant. Now, secondly talking about the notifications. Now, it is very useful as it will provide us with regular notifications about the health of the purifier plant. And it will regularly notify about any ongoing activities as well as the probable changes in the filter. Thirdly, which is very important, the system has a unique capability. Now it will not only just locate the fault or detect the fault, but it will tell us the exact location or the exact electronic component which has been damaged, or if there is something which is not functioning properly. So it will give us all the information about it. It will be very useful for the technicians. It will be very useful and very helpful to them. Now coming to the technicians. Firstly, analytics for identifying the issue according to the air parameters. Secondly, a list of recommended tools as per the problem identified by the analytics engine. Now thirdly, it will also have GPS information of the purifying plant having the issues. And fourth, priority based on the usage statistics of the purifier plant. And the most important, a mobile app to up to date and to give you the status of the purifier, considering that the technician is more often on the move. Now talking about the proposed solution for the service provider. Firstly, it will provide with a dashboard with all the health and the analytics of the purifier plants. Secondly, prediction of the components to be stocked based on the current usage trends. And a very important point, which is a geotagged information of any priority request or old issues of concern. Also, it should monitor any untenanted issues with the purifier plants. Now coming to the working behavior of the smart plant. Now this system is a smart plant that purifies the air present within the room. Now this purification process, it can be initiated and terminated by the user as well as the system. It will itself purify the air based on the sensor readings. So if the sensor reading deviates towards a statistically above than standard range, the purification of air is initiated. There will be also a display on the device which shows real-time air quality measurements. Now, the display is also incorporated for alerting the user of any faulty behavior or performance of the device. The screen will also display the real-time temperature and humidity of the surrounding. In addition to all these features, the device will also detect the domestic gas leakage and unwanted fire in the surrounding. Aesthetically, it is perceived as a plant giving user a natural breathing air and removing intoxicants.
Let's unwrap the abstraction to next level by discussing and understanding the features of the product as follows. Time to time air purification, which will ensure the cleansing of ambience, real-time air quality sensing, which is really important to know the status of atmosphere inside your home, LPG detection, which could critically stop the disaster, and time to time room freshness. This is the proposed architecture, which is explained as follows. As you can see, this is a bonsai. Here, all the sensors are interfaced with the system and data gathered from the environment is published to the broker, which is a ThingSpeak cloud using the MQTT protocol. The predictive model is injected over the cloud API where the desired analysis and predictions are required. For an efficient user experience, we propose to incorporate a touch display panel for navigation and control of the system. SOS calls are also a part of the solution for emergencies. For the service provider, each system has been embedded with a GPS module for geotagging, which gives them an edge for planning and managing the consumer queries. The service provider will access the data of any system for checking the status using the dashboard. The system will help in resource planning for the service provider. As per the technician support, the system is proposed to be incorporated with a voice prompt for guiding a naive as well as an experienced technician smartly.
Following are the list of hardware components that we have used. We have used fan and BLDC motor for the purification of air, a HEPA filter which is very essential for the purification of the air filter, GPS module for geotagging, LEDs for changing the color, touch display for user interface, and SOS button, MQ135 sensor for measuring the air quality of the environment, a flame sensor for fire detection, MQ2 sensor for detecting various contaminants in the air, ESP32 which is our Wi-Fi module, DHT11 sensor which is used for measuring temperature and humidity, the housing which is going to be the physical components, power supply for supplying the power to our product.
Let's look over the technologies and software to be used. The environment that we will be using for are as follows. Arduino IDE for programming the ESP8266 module at the hardware, MATLAB for simulation and predictive modeling, Android Studio for application development, and ThingSpeak Cloud for cloud management. Following are the tools and libraries used. PopSub client will be used to implement MQTT protocol, predictive maintenance toolbox which is provided by MATLAB, soft serial library, ESP8266 Wi-Fi library, ThingSpeak library, and Simulink, and ThingSpeak MQTT API. Let's discuss predictive maintenance model. The failure dataset is generated with the help of Simulink. A mathematical model of the system when used in Simulink helps to generate the failure data required for training the model. The dataset is a time series data. Time series forecasting is done with recurrent neural network algorithm. The Bonsai model fits the time evolution of a condition indicator and predicts how long it will be before the condition indicator crosses some threshold value indicative of a fault condition. The model compares the time evolution of a condition indicator to measure or simulate time series from system that ran to failure. This model can compute the most likely time to failure of the current system.
Now, for capturing the end user experience, we are proposing an application for user to get periodic updates of air quality in real time over the application. The system will also feature a touch display for an enhanced user experience. The display will help the user to operate the system for navigation and its controlling.
Project plan. Building the working model. To implement the working model, we have enlisted following steps to build the product. First, we need to plan out the essentials and enlist the required hardware. After planning comes designing. We have already designed the required architecture for the entire hardware. For ease of implementation, we need to evaluate the functioning of hardware in response to various inputs. Therefore, we plan to simulate the hardware using Simulink in MATLAB. For building the predictive model, the next step will be to generate the dataset required to train the model. The dataset will be generated using Simulink and Predictive Maintenance Toolbox in MATLAB. Once the dataset is generated, the model will be trained and the data will be pre-processed. We will be training the model and this trained model will be injected over the cloud, which is ThinkSpeak. For user accessibility and user interface, we will be needing to develop an Android application which will cater to the needs of user. The next step will be to reassemble the hardware. We have already gathered all the sensors and electronic components required to build the model. All the sensors will be interfaced with the microcontroller, which will be our ESP8266 module. We do not intend to use a Raspberry Pi board because for all the heavy processing, we will be relaying the information to the cloud. Next is programming the ESP module. We will need to test the working of the programmed hardware and sensors. Once the testing of sensors and hardware functioning is completed, we would interface the hardware with our ThinkSpeak cloud. We will be configuring the ThinkSpeak cloud for setting up channels for storing the data. MQTT protocol will be used to publish the data to the cloud. After the completion of the mentioned steps, we will be testing the entire product and we will look for any bugs in hardware and software. And after successful testings, our working product will be deployed.
Following is the cost analysis for our product. The total cost for our product is 5,975 rupees in total.
So, how much effective is Bonsai? We have compared an air purifier at low pricing with Bonsai. The estimated cost for Bonsai is 6,000, whereas an air purifier available in this range costs up to 8,000 rupees. Because of the predictive maintenance of the system and better service quality, the lifespan of Bonsai is estimated to be better than air purifiers. The estimated power usage of Bonsai is around 24 watts. The data sheet of the BLDC motor that we will be using was referred for calculating the power consumption.